So let's look at some examples where we convert parametric equations to Cartesian equations. So determine the equivalent Cartesian equation for the following parametric equations. X equals 2t and y equals t plus 3. So firstly, label your two equations, equation 1 and equation 2. So from equation 1, we have x equals 2t, which we can rearrange in terms of t to be x over 2. Sub into equation 2, which is y equals t plus 3. So that becomes y equals x over 2 plus 3. And that is our Cartesian equation. And you can see it's a linear line. The gradient is a half and the y-intercept would be 0, 3. Have a go at the next one at yourself. Pause the video. So labeling equation 1 and 2, from equation 1 we have x equals t minus 3, which we can rearrange in terms of t, and that would be x plus 3. Sub into equation 2, which is y equals 2t squared, so that becomes 2 bracket x plus 3 all squared. Expand out the bracket, we have x squared plus 6x plus 9. Expand the bracket again, 2x squared plus 12x plus 18. And that, you should see, is a parabola. Okay, next example is a little bit different. Label our equations 1 and 2. And what we're going to do, instead of getting t on its own, which is quite complicated looking at those two equations, we're going to square each equation. So if we square equation 1, we'll have x squared equals 4t squared over 1 plus t squared all squared. And square equation 2, we'll have y squared equals 1 minus t squared all squared all over 1 plus t squared all squared. Going to expand out the top bracket, I'll end up with 1 minus 2t squared plus t to the 4 all over 1 plus t squared all squared. Now I'm going to label these equation 3 and equation 4. And if I go equation 3 plus equation 4, I end up with x squared plus y squared equals 4t squared over 1 plus t squared all squared plus 1 minus 2t squared plus t to the 4 all over 1 plus t squared all squared. Now what you should see is the denominators are the same. So I can bring my numerators together. So I have t to the 4t squared minus 2t squared is plus 2t squared plus 1 all over 1 plus t squared all squared. And then I can factorize the numerator, t squared, 1 and 1. So that's t squared plus 1 all squared over 1 plus t squared all squared. Now, you should be able to see that these are the same. So they're going to cancel to give 1. So I have x squared plus y squared equals 1, which is a circle.